Good day, everyone. Today we are going to start our distance learning on physics. This lesson is for grade 10. It's for grade 10. Please turn your book on page 2, 4, 6. And we will start with the topic electrical quantities. Electrical quantities. So what's an electrical quantities? Here we will discuss two types of different phenomena illustrated in page 246 in introduction part. First phenomena is when you brushed your hair and seen individual hairs standing on end. So first one, when you brushed your hair, you will see some hairs or individual hairs standing, some of them standing on end. This one phenomenon. Okay. And wondered why this happens. So the second one, would you like to know how to stick a balloon to a surface without glue? So the second phenomena here is stick. We were going to stick a balloon on surface without any glue. So there are two types of phenomena here. We are going to discuss them or explain them by physics. So this section explores how and why these things happen. Why, when you push your hair, you will see some individual hairs standing on end, and how can you stick a balloon on a surface without any glue. So physics will explain why these things happen. Both of those phenomena, they are both the result of movement of electrical charge. So both of them, they comes under the result of movement of electrical charge. So what's an electrical charge? What do you mean by electrical charge? In this topic, you will learn in this part here today, in this class, you will learn the basic theory of or behind current electricity. As well, you will also learn how electrical quantities such as the charge, current, force, resistance are related. So electrical quantities such as a charge, electrical or current, force, resistance are all related to each other. All of them are related to each other. So we here have two type of phenomena. First one, when you brush your hair, you will say like a standing individual hair standing on end, and how you can stick a balloon on a surfaces, different surfaces, without any glow. So both of them, they come under the result of movement of electrical charge. So in this topic we will learn what's the relation between charge, current, force, resistance, which comes under electrical quantities. So please turn in your book on page 247. We will start with electrical charge. Electrical charge. Electric charge. Individual hairs stand on end after brushed, and balloons stick to certain surfaces without glow as a result of movement of electric charge, as we discussed before. So the movement of electrical or electric charge or the current through some medium will affect those kind of changes. So we will move to some material which known as conductors and some materials known as insulators. So the result of movement of electric charge to the movement of electric charge will be happening, or it will be through some material, some kind of material. Some of them is known as conductors, and some of them are known as insulators. Conductors and insulators. So what's the difference between conductors and insulators? Substances that easily allow electric energy to pass through them are called conductors. So any substances, any material, any kind of material that easily allow electric energy to pass through them easily are called conductors. So what's an insulator is? Insulator is as the opposite of conductors. So conductors are not insulators, and insulators are not conductors. Those that don't are called insulators. All metals are conductors. All different metals are conductors. In a metal structure, if we come to the structure of any metal, the metal atoms exist as ions surrounded by electron cloud. We will draw it here. So any metal, it will be like this. The atom of any metal, it will be something like this. There is some electrons here. So this is a metal structure which consists of some metal atoms. This is a metal atoms, and this one is an electrons. So when the electrons are moving through the metal, here, all electrons or some of the electrons here, they bump into the metal ion and experience resistance. They will bump to the metal here and experience what do you call is resistance. Resistance R. So the resistance to the electron flow or current, so it's in different conductors, the flow of electrons is different, and so the conductors have different resistance. For example, copper is better than or better conductor than iron. The copper is better than conductor than iron. So this is, that consists of any metal structure which is ions are surrounded by electrons. Ions or atoms, metal atoms surrounded by lots of electrons here. We will draw this structure with some more details. We will draw it again with some details. So please turn your book on page 248. On page 248, please look at table 4.1. There's a comparison between conductors and oscillators. So first column is the name of conductor or oscillator. Second column, is it metal or non-metal? The last column is conductor or not. The first column starts with silver, copper, aluminum, iron, and so on. And for example, the first one is silver, and the silver is a metal and is the best conductor. And we can move through them, and we say some of them is conductor, some of them is oscillator. So the some of them is called semiconductor, which is not completely conductor and not oscillator, and is not an oscillator. So it's called semiconductor. We will move to the topic electrostatic charge. We will discuss the charging oscillators by friction. How we can charge oscillators by friction. Material such as glasses can only become charged when they are rubbed. So this is because they are oscillators. Electrons don't move easily through an oscillator's material. So when extra electrons are added, they stay on a surface instead of falling away. So conductors such as a metal cannot be charged by rubbing. So we will draw the last figure in some more details here to say where is the structure of an atom. The structure of an atom, any atom, it will be something like this. There is an protons and some neutron, they will be in the center, here and surrounded by electrons. So this is the structure of an atom. This one is electron or electrons. This one is a proton. This one is neutron. This one is neutron. So all atoms are made up of three main parts. This is the first one. This is the second one. And this is the third one, neutron. Three parts. Any atoms of materials are made up of three main parts called electrons, protons, and neutrons. As we can see here in this figure, electrons are the thinnest or the smallest of these and have negative charge. Electrons is a negative charge. Charge is negative. Okay. Proton is a positive charge. So electron is the smallest one and is negative charge, and the proton, it comes with positive charge. And protons and neutrons have about the same mass. As we can see here. This is the mass of proton and this is the mass of neutron. Electron is smaller than both of them, is smallest one. This is the smallest one and comes with negative charge. Proton, neutron, they have the same mass. And proton is positive and the neutron protons have no charge. So electron is minus or negative, proton is positive, neutron is no charge. No charge. And always proton, neutrons, they comes at the center here. Electrons are moving around them here, around the neutron and protons. In most atoms, there are as many electrons as protons. In the normal case, the number of protons is equal to the number of neutrons. The number of electrons here is equal to the number of protons. So negative charge is equal to positive charge. This is in the normal case. And with most atoms, there are as many electrons as protons. The number is equal. The number of protons is equal to the number of electrons. And electrons is negative and proton is positive. So normally an atom has no overall charge. Because what? Because the total positive charge of the protons is equal to the total negative charge of electrons. So when there are more electrons than protons, if the number of electrons becomes more the number of proton, what happened here? So the atom carries an overall negative charge. The atom will carry an overall negative charge. We will draw this figure again with some more details. So if we have like proton, neutron, 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 proton, they are all in the center here. And we have like how many electrons here? 2 electrons. This one is figure 413. هو البوزيتيف charge. This is positive charge. So when there are more than electrons than protons, if the electrons is less than, this is electrons, 2 electrons, and how many protons here? 1, 2, 3. So it will be positive charge. So if the number of electrons is less than the number of proton, so it will be a positively charged. And the opposite, if we have put like in figure 4.12, we add 2 electrons here, one is here and another one is here, and change or keep the same number of protons and neutron. Neutron doesn't affect, but we focus always on proton and electron. So here electrons is greater than P, protons. The number of electrons is greater than, electrons is 4, protons is 3. So electrons, the number of electrons are greater than the number of proton. There is an overall negative charge. So the charge is negative. So the atom charge here is negative. If the number of electrons is less than proton, so the charge is positive. Keep this rule in mind, please. So this is all about electrical quantity. Next class we will start with attraction and revolution on page 250, and we will go through questions on the same page on this topic. So this is all for today. Thanks for listening and see you next class.